So what I want to talk about is, well, I think there's a very interesting intersection that is happening at the moment on the whole evolution of security and development. And for the guys who've been here around OWASP for a long time, you know that for a long, long time we've been asking to be taken seriously. For a long time we can see the disaster coming. We can see basically the train wreck, right? And in a way we kind of at the point where it's actually starting to happen. And actually, you guys can still hear me like this, right? Or do I need that for the recording? It's probably
for the recording.
Oh, okay. So what I've been doing is I kind of moved and I think evolved in the last couple of years where I've basically been developing for a long time. I kind of tried to calculate it and I realized I've been actually coding for about 25 years. I'm actually from the ZX Spectrum generation, so if everybody remember the Spectrum and the Amiga, right? And when the 286 was actually fast and all that kind of stuff, right? I've been doing application security for, again, about 13 years. When I was from the generation, so we can actually, buy Hacking Exposed, and then go to the internet and going, okay, page 56, let's try this, right? And then you really learn a lot, right? And I've been doing the OWASP-London project again for quite a long time, which is basically my brain in the kind of a tool and project, which probably means that very few people in the world can actually use it. But it's actually very usable when you kind of get your head around it, and it's very powerful. Even to these days, I'm doing a security assessment, and I still find it's one of the best tools to do security analysis. Again, you need to get your head around it, but it's very powerful. The thing I've done for the last couple of years is I kind of moved, not only I became a developer for a while, where I really embraced, and I shipped code, and I embraced the development, so I really go into DevOps and the whole kind of development mindset. So, I realized I had written a lot of code, but I never actually shipped code. So I was actually responsible for a team. I really, work on that, and I really understood finally where testing and how security fits in the whole development lifecycle, which I want to talk about. Recently, one of the things I've been doing is I've been leading application security teams. So I kind of go to a company and help to set up security teams, kickstart the whole process, really, jumpstart the thing. So I'm doing it for the help, and I'm doing some stuff also for the VC recently. And I also do a lot of training. So, and I was actually doing training today. I do about probably 2 days a week of training. And my training is basically I go to a company and says, the developers, fire up your laptops, let's look at your application, right? And in most times, it's quite interesting what we find in all massive corporations in the UK, right? So that's my blog, that's my stuff there. So the main thing I want to talk about, don't hack my laptop, please. All right. So the main thing I want to talk about is, in a way, when you become a developer, you really start to embrace the whole software craftsmanship and the whole quality and the whole testing. And I basically, one of the things I found very interesting, and this probably comes from my days of being a security professional, where in the beginning, if you think about it, you pick this app where these guys have been working for years and years and years. You come along, you have a week, and basically your job as a security professional is to find as much shit as you can do, right? And the point is, if you can find enough stuff with enough flashy demos that they don't have to ask the question, what do we need to do to make this secure? You've done your job, right? The hardest part is where you don't find a lot, and they start to ask the questions, ooh, so does this mean that we are secure, right? So I always manage to dodge that bullet as a consultant, but I also start to understand that, in a way, what was the real game we're playing? And the thing I start to realize is a lot of it was about, when I start to get to developers and start to talk to them, I realized what I was really on about was quality. It was actually, in a way, was this concept of software craftsmanship. It's all about software quality. So as I became more and more involved into development, more and more evolving to really good developer teams, like not the kind of teams that they don't care about stuff. They are really good. But the problem is, sometimes the question is, how do you define quality? How do you actually, in a way, measure it? How do you measure quality? So there's a lot of things that people talk about, we should do this because of this, we should do that because of that. And in a way, going back to my consulting years, I remember thinking that I'm in the business of providing highly defensible findings. In a way, I was finally realized that I was having really focused, in a way, objective architectural discussions. In a way, it was interesting because I was able to cross over from the dev where I could talk lines of code to the point where we can argue about how to code to line by line, all the way to the systems architect, all the way to the business analyst, all the way to the board. And I was able to breach all those because I was very objective. If somebody who had a point on quality, I was able to have a counterpoint on security. And what was interesting is I started to realize that I'm actually talking about architecture. I'm talking about code quality. So I realized that I have a way to measure it. I have the way to look at an application and say, this is good, this is bad. Not because I don't like the language, not because I think, that PHP is a shit language and Java is great and Scala is amazing. Even in the last couple of weeks, I saw an amazing PHP application and I see a Scala app that the guys have no idea how it worked, right? So again, you can create great stuff in one language. These days, my main view is that, can you test it? How fast can you deploy it? How much do you understand about the unintended consequences of the application? That tells me more about how secure you are versus, how much, what technology you use. Now, you can create amazing secure applications in C++, right? I was talking to these guys and they were doing assembly code that runs half the planes. It's like, whoa, but actually, they can do it because they have the skills and the process. Of course, that they had processes that are like 50 times better than most of the average software development companies, right? But the thing about this is, here's my kind of thesis and concept, right? I believe that we can actually use application security to define and measure quality. And what it means we can have very pragmatic and objective analysis of why something is good and why something is not good. And what's nice about this, it gives us a path to talk to developers. In fact, what I find is that the developers, when they get their head around this, they love it. Because what I'm really talking about is I'm talking about the non-functions requirements of software. So if you look at software, it's apps, websites, web service, APIs, tools, build scripts, everything. The way I look at it is everything that moves. Every time you make a change, you need a test. You need a verification. You need to understand it. I've seen global Fortune, whatever, in England, FTSE, 50 companies in UK being brought down for hours for one line code. One character brings down a whole website, right? And it's because of lack of testing, lack of understanding of the side effects. In security, everything we do is about the non-functional requirements of software. That's why sometimes people hate us, because we go to an app and say, this app is beautiful, it works, everybody loves it. What we say is, hey, could you just refactor it, make all these massive changes, and leave it just working just like it was, right? And they look at you going, but that has zero business value, right? You just ask me to do highly critical, highly sensitive stuff that we don't even know how that thing works. You just ask me to come in, chop a whole bunch of things, right? Do the typical, just encode it. Isn't it? I'll just go there and just encode that little thing there, right? And of course, as from a security side, we never have to answer what the hell are the side effects, right? Of changing that little encoding here, of modifying the app that way, adding authorization here, which breaks half the company, right? So what I realized that what we're really doing is this. We're measuring, in a way, how the application works. And you know that when you do a threat model with a company, and the architect grabs a pen and starts drawing, right? Where are all the latest update documents, right? This is like somebody goes to this building and say, hey, I need to do a security review, where are all the doors? Where are the things? And the guy starts drawing you a draws you the building, here's a door, here's another door. And you're like, whoa, dude, where's the actual update maps of this place? But in software, we have that. There's very few teams in the planet that know exactly the entire attack surface, that know exactly how it works. And knowing the attack surface is the beginning of playing the game. If you don't even know the attack surface, you don't even know the permutations, the multivariations, what is supposed to happen when people talk to that thing. So in application security, I realized we were doing is we were asking how it really works. So what's really interesting is, and you find this, if you find a mature application security team, you find that they're the only guys in the whole company that knows how many websites you have, right? Where they are, who the hell owns that thing. I used to work for ABN AMRO, right, in a great team, and our job was to hack the freaking planet, right? We would go, today, Brazil, and let's go, what's in Brazil, right? So we would scan Brazil, right? And then we go, hey, Chicago, great, what's this? And we go to those guys and say, hey, man, we found this in our data center, has lots of problems. They'll go to us and say, hey, do you know who owns this? Like, dude, it's on your territory. It's on your data center. It better be ours because, it would be even worse if it's not ours, right? But that's the kind of baseline. So the security guys actually know what's going on. So you need to use that to your advantage. So the way I look at it is the application security, and I will draw a line between the InfoSec and the application security. And by the way, the InfoSec guys, they're amazing. They do a great job. If you don't have them, you probably should start with them, because without freaking firewalls and network policies and all that kind of jazz and managing secrets and all the great amazing stuff they do, forget about application security. But once you clean that up, you need to go to application security. And none of those guys can do application security, which is a problem. Which basically means that if you're all developers, or who you are developers, you should really become application security experts. Because not only are you going to get paid twice, which is always good, right? There's a massive gap in the market, right? Everybody here, you know, is a bit cheeky, you know, it's a bit cheeky for him to say, hey, Skype is hiring, right? Because I think half the people here are hiring. But guess what? You guys host together, so you get a free pass, right? But it's true, right? It's the same thing. I have some business cards if you guys are looking for a job, but, you know, but it's the same thing, right? It's all a problem. So I think application security is a great place to be, right? And the thing about this is that, in a way, with application security, we can actually measure the quality of applications, which is a very interesting concept, because now we go into the heart of what developers care. In fact, we go to the heart of what business cares. I was in an office today and they had the quote for the cyclist guy saying, it's all about the 1% improvement, right? So I go, great, you guys spot that, and every time we talk about the salad of cookies that you guys have on your homepage, and the freaking, you know, massive sausage fest, which is your scripts that you get from the other people, let's look at that, because I just want 1% at a time. One cookie at a time, let's get rid of it. It's all about the little things, right? So, in a way, application security measures the unintended side effects of coding. So the way I look at it is, my game is about saying yes. I never say no anymore. It's all about, hey, you want to do something? Great. You want to, you know, Miss Project Manager, so I'm making on you. So Miss Project Manager, right? You want to go to these guys here and give them a crazy deadline based on 2 weeks, because I think it's 2 weeks, and when they argue back, you go, oh, I'm going to be nice to you, I give you 3 weeks, right? You know, she's going to turn and says, fine, there you go, I can deliver that. By the way, I need to talk to that guy. He's worth 50 million pounds of potential damage. Guess what? You now have to manage that. And what you have to do is go to your boss, right? You know, because ultimately you're a developer at heart, so you understand it, so you go to your boss and go, hey, you know that thing you asked me to do, right? Because you said I want one of those things over there, right? Or maybe it's not as bad, but, you know, sometimes it is, right? I want one of those, can you do that? And you go to your boss and say, by the way, you have to accept this risk, right? So for me, it's all about passing, you know, making sure that the business owners understand the risks, understand the side effects of what you're doing. So for me, like, you know, your program was great, but the way I look at it is, you want to go live? Go live! Absolutely, man! Totally! Just click here. So my JIRA workflow has a nice little button called Accept Risk, right? So a great analysis, imagine they're doing jet engines in 1 week, you know, another team comes along and says, hey, guess what I just sold? So it's like that, isn't it? Guess what I just sold for $1 million to that company, it's great. You need to do a golf cart, right? And this guy's going, we're doing jet engines. Our whole research is jet engines, because now you guys are super intelligent. You've done a jet engine, come on, surely you can do a golf cart, right? So what you guys do, you don't say no, you say, great, I can deliver it. He's a golf cart. By the way, you can say 2 things. By the way, we have no idea what's in the engine. It was a dude, he did it, he's left, he's a genius, but we have no idea what's in that engine. Feel free to drive it, okay. Or you can say, actually, we know what's in the engine. We actually slapped a nuclear reactor in that thing because we have to slow down the jet. So we use nuclear power to do that. It's totally cool. And guess what? Your specs didn't say that it should be okay not to be crashed or to have an accident at 30 miles per hour. So there you go. There's your golf cart. But just don't crash that thing. Right? So you say yes. You want a golf cart and crazy deadlines using the technology stack that we have. Cool. Without being tested, there it is. Click yes. So that makes a massive difference in those things. Now, here's something that is very dear to my heart. So actually, I should put I need to take a screenshot. And by the way, I'm delivering this presentation in a couple more places, so I gave myself the problem to create these slides, so I'm kind of improving it. So this is one I need to improve, because I want to add actually a lot of other books in here. But here's the big myth that I think we have always pushed in an unofficial, sometimes, or official way. There's always this myth that if only the developers could freaking write secure code. Those freaking guys are writing secure code, if only they can do that. Which basically means that if all the developers were security experts, they could do the great thing. Isn't it beautiful? They can write secure code, right? Now the thing about this is a massive myth, because secure code has very little to do with developer skills and ownership, right? She can actually be the Chuck Norris of code, right? She could be the best programmer. It has to be promoted to manager, but let's say she wants to get back into coding. She goes to her team, right? Doesn't matter how good she is. she will be the most inexperienced developer in that team. Now, if she's amazing, she might get there to a level of mastery in days or weeks, where if another person is not has experience, it might take them years. But the bottom line is that it doesn't matter if she's the best programmer and the most secure programmer in the world, in an environment where you don't understand the side effects, it doesn't matter, right? And that's not, of course, not to say that, of course, if developers have security experience and developers are really good, they cannot write secure code. That's not what I'm saying. What I'm saying is that it's not the other way around. Now, here's the thing, right? Software security and security is a consequence of the software development environment. That's why I'm saying I can measure quality and I can measure it via security, because I can look at your software development environment and I can bet with you that you will have security vulnerabilities, or probably you don't have security vulnerabilities. Right? Because I can look at your testing, I can look at what you do, I look at how you guys develop, I can look at what you guys have, and know exactly what it is. It's the same thing. If you guys, look at a car, and you look at that factory, and the thing is freaking falling apart, it's totally crazy, right? You can see it's totally out of control, it's polluting everywhere, right? Even although the car might come out really good, what confidence do you have that is actually really good? You look at how the Tesla is built, and you have really confidence that it's a really rock solid car, right? The same thing. And the reason I know that is a myth is because I'm not able to write secure code. So I could put my hand up. And I realized this when I was working for a security company writing software, when I was shipping code, and I remember hearing the guys from the US saying, this app is great, it's super secure because Dennis and his team, and most of them are security professionals, are writing it. And I'm like, whoa, 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 whoa. It's not because I'm writing code that I'll actually make it secure. And I understood why eventually. The reason why is when you're coding, you have a mental model of your application. You build a mental model that basically maps, in a way, it's like this kind of horizontal slice of the application. By the way, O2 has really cool called method streams, where you can actually read it in online, but in one page, but that's a little O2 thing. But it's very hard to visualize what's going on. I also realized that when you're developing or coding a bug or a feature, you are rewarding for getting it done. So the idea that you're going to go on a tangent to follow the rabbit hole just because you think this is a bit dodgy, come out on the other side and going, oh, I didn't find anything, woohoo, right? The project manager is going, wait, where's my feature, right? Why did you spend 2 days hunting ghosts? So it feels very kind of not efficient, so naturally you avoid it. Or even if you do a couple, you get this false sense of security. So what I realize is, when I'm writing code, and I want to put my hand up, I think I'm a decent developer, and I think I'm a decent application security expert. Right? But I'm saying that the best thing that I have is I can say, I think this is dangerous. I need to come back to this later. Right? And I think that's very important because, in a way, the only time I can write secure code is when I'm writing code that comes out secure. And for me, that is the key concept. The key concept is to make sure there's two paths for development. There's a motorway over here that you can just go and push to production. In seconds, in minutes, with all the automation, with all the stuff that, for example, he was talking about, where you can do these checks. And then this other lane here, where it has to be expensive, right? And that's the name of the game. The name of the game is to make sure that 90% or 95% of your code goes into the motorway, and 5% goes into each extra lane that has the extra checks, has the extra security. So in the example that he was talking about, if we have this last kind of test that we're fuzzing the whole thing, if one of those fails, that code needs to go into this lane because it needs to be code reviewed. Here's a very simple thing. If you guys have web services, if you don't know your attack surface, or even more interesting, even if you know your attack surface, if you add a new method, right? So you write web services, right? So if you add a new method, does any test break? Right? You went to your web services, you went there, you added a new method, the way Java, servlet, controller, whatever it is, nodes, add, use, thingy. Do you have any test that breaks at that moment in time, from there all the way to production? And and this is the thing, if you had, right, your answer would be yes. Because you know that every time you add an endpoint, you know exactly what test you need to change. Right? And that makes a massive difference. So what it means that you can go in, create a spectacular vulnerability, dramatically increase the attack surface of your application, and nobody will notice. And if you guys have commits with like 1 kilometer long, right, nobody can review that thing. Right? So for me, a commit, in fact, if you don't use Git, that's already a security risk. Right? Because, or Mercurial, right? But Git should be the one, right? Because there's workflows that you need to do. If you have Git commits or if you don't use Git flow, that's a security risk. Yes, you can probably do it right, but most likely you're going to shoot yourself in the foot, right? And the cool thing of adding this as risks is what you're doing is you're playing a mid-term game. Because all you need is somebody to actually really do a big vulnerability that you catch, and then you have all this trail of things to say, look, see, I could have caught that 2 months ago if you guys have heard what I said, right? So this is a great analogy, right? I'm actually stealing this from a guy called, I think it's David Kelly, no, David Rice, I think. He did an amazing keynote, one of the best keynotes I've ever seen in OWASP, California, 2011 or something like that, right? And and he's the guy who wrote Geekonomics, right? And he actually had this thing which is quite interesting. So basically, these pictures you see here, the river, the photos at the top, they are rivers catching fire in the US, right? So what they are is they are in the 1940s and 50s, rivers would catch fire, and people would not think that's a problem. In fact, they were more worried about the damage to the docks, right? And the solution was to make the docks fireproof, instead of looking at what the hell is happening in the upstream of this river to actually pollute it so much that it makes it on fire. People will look at these big smoke pipes and say, that's great, that's progress. If your town doesn't have one of those, you don't have good jobs, you don't have good things. Security and application security today, this is where we are. Most companies are polluting. What we haven't figured out is how to measure. And what happens is our definition of rivers getting fire is when our apps and our websites and our users get compromised, right? But no, we don't go to the root cause. So TalkTalk gets owned and they get away with it because the real headline should be kids, bypasses enterprise-grade company's profile. Even more interestingly is what could have happened. So the definition here is TalkTalk was building a nuclear plant. This guy comes along, which is pissed off or whatever, knocks down a sidewall, that thing sends some pollution, they blame the kid. What they should be asked is, hey, do you realize that next to it there was another one, if that actually was really more dangerous? So we're still not asking those very important questions, right, in our world. Now, the other problem with this is technical debt. It's a really bad analogy, right? Because first of all, the developers are the ones who pay for it, not the business owners. So basically means the business owners get rewarded for delivering stuff. And by the time the real technical debt hits, those guys are long gone, where the devs are still there. The other thing is, I've actually seen businesses that think that technical debt is great, because they view it as leverage, right? It's like business, right? If Skype, or whatever, it's a big company these days, doesn't have a lot of debt, right? You can actually borrow money to buy that company for them, right? Using their debt, right? That's how Manchester United got bought, right? That's an interesting thing. So you have to be careful, right? So the way I look at this, pollution is a much better analogy, because you don't say you're buying this technical debt, you're saying here are the side effects. Here's your nice little golf cart with a nuclear engine on it. So don't crash this thing. Apart from that, it's great, right? But here's the thing, right? Now let me do a nice little demo so I can show you a bit what it means. So let me kind of hack you. Because I was on the software craftsmanship community, so it's always nice to hack their website, right? And I know this is not a big one, but it's just a nice one to show the points I want to make, right? So first of all, you can do something like this, right? You can see I've kind of modified a little bit because the real one is not about well-crafted secure software, community of website professionals, but I'll get to this guy in a second. Let me first show you something interesting. And by the way, this is a massive one. I don't know if you guys know a lot about this one, but this is a really big vulnerability from last year, right? So let's look at that website. So my point, my kind of premise is I can look at this application and I can make a huge amount of analysis on its security. So the first one is they're not using SSL, right? First big one, okay? Little thing, but it matters because it means that they don't have somebody there that is actually pushing it, going for it, making sure they cross all the T's. And of course, SSL is just the beginning. You make sure SSL is correctly configured, make sure you have HSTS headers, make sure your cookies are marked as secure. It's not something simple. In my JIRA, I will open 7 tickets just for SSL stuff, right? Because you have to get it right. It's not about, oh, flick SSL, right? That doesn't work. Then that other interesting thing is you go to the source code and you realize that the source code of this is, okay. They embedded this. Oh, that's interesting. Okay, this changed from yesterday. All right. So, but actually, it's a variation of it. Ooh, look at this. Okay, that's annoying, but that's not bad. Okay. So yesterday, right? Actually, I kid you not, this morning, good. And actually, I showed this to some guys this morning. So this morning, let me pick another website, I think. And I can hit these guys because I'm actually going to work and I'm going to do some stuff in there, right? So, and then, it's again, it's public service, right? Actually, BBC is great because one of those places I can actually say that you get this right because I actually care about you, right? So the other guys looked a bit like this, all right? Although I think, where is it? Actually, BBC is not that bad. What's another website? Let's try Marks and Spencer's, right? So let me just go. That is cross-site request forgery on that guy. Okay, so that's actually not that bad. Okay, well, actually, big salad of JavaScript, right? So what I was actually looking for was something like. Okay, so they don't have. That's cool. All right. So yesterday, what they had there was they had all the JavaScript straight away, right? Basically, they had every single JavaScript as an individual thing. For me, what that tells me is that they didn't have, probably still don't have a lot, but they didn't have a continuous deployment. Because when you have continuous deployment, one of the things you do is exactly something like this. Although I could probably argue that you probably want to put this all together in one file, but this already means that they added a consolidator, right? Where they basically start to add these scripts. Okay, so I can see what they're doing. So they're actually inlining the whole thing. So you can see they added one script and the other script, which is interesting because usually it's all done.
Don't forget, we saw them a week ago, right?
Yeah,
so we saw them about this. They must have
all right, so they've added all. So they added all the scripts in line. Okay, it's a good start, right? But really, that should have been consolidated and minified. In fact, they didn't minify some of these, right? So that's not minified. And basically, and you can see, well, that's a small little thing. But actually, being able to have continuous deployment, being able to have things that can run in Docker, that can minify, that makes a massive difference. All those little things, right? Now, the other thing that's interesting about this, when you look at the code, is they basically have this part here, right? Which basically you can see they're using this this kind of templating language. Now, the reason why this is so important is because what they're doing here, it's a very typical mistake that you do in multi-tier systems, where you trust the upstream. So what they're doing is they're saying, I'm not going to validate any of my data because I'm going to trust that my upstream provider of my data is secure. So that's the typical one where you depend on another service and you don't protect because you expect that service to not give you payloads, right? The problem of this is the situation, what happens if you get HTML from the server, right? So one of the things that I've done here, if you look, for example, this, what I've done was I've modified the code, including I was able to put HTML on it. So that means that in this case, if you see there, right, if you get this from the server side, right, your client will not render it. And then that means that the server has delegated, in a way the client has delegated to the server its security. And you see these all the time. And even if you guys use things like Angular and others, you have to be careful because it's so easy to sometimes create these problems. jQuery is a nightmare, right? Because jQuery is about DOM manipulation. But what happens here is that, in a way, to test this, you need to create servers that can actually send you payloads. They need to actually be able to simulate what happens if one server is attacking me. So in this example, if you have a web service and you consume data from him, what happens if he's now starting to send you back data? Because if you can't handle it, we need to chase these guys out. And then what happens if he gets bad data from her and bad data from him? Right? I worked with these guys the other day. It was a location service. It was great. You had this website that shows you location, where you are, and all this stuff. We realized that UI had a cross-site vulnerability like this. You think, well, not a big deal. The server side is rendering data, but where does the data come from? Oh, it came from his service. We follow these guys. Where does data come from? Oh, it comes from the importer. Where does data from? It comes from this third-party website that you can actually add a crowdsourcing kind of map thing. Right? So here's the problem. The way I look at it is that original lack of encoding was a pollution. That original lack of encoding forced me to go all the way down and understand the root cause, where I shouldn't have to care about that. Because in a way, from a view, your job is to create safe HTML. Right? So again, those little things, and now means that we need to care about the server, which means we need to care about who can edit this, which basically means that wherever you can maintain this can be blind spots. But the more interesting one is this one here, right? So the more interesting one is if I come in here and I do a search for something, right? So if I come in here and I go network and I search for Doug, right? And now what's interesting, you can see that it took 304 milliseconds. By the way, this is going through my phone, right? So again, 108 milliseconds. Actually, no, I want to do the search. So Doug, and you can see here that I actually, okay, here's my search, right? So now you can see that if I reload this, I get 100 milliseconds. I do again, I get 200 milliseconds again. So that's kind of interesting. Now if I go DOU, I get 230. Okay, a bit more, right? Let's see if I just, go like this. Now, okay, 500 milliseconds. Another 500 milliseconds. So what's happening here is, see, the way kids do denial of service, or amateurs, is they send you a huge amount of traffic. The way you denial of service a website is you profile the app, you build a nice little QA script to be able to invoke most parts of the applications. You find the medium expectant value, which most likely will be the network, right? Request, anything that's above 20 to 50 or 100% of that value is most likely denial of service, is an endpoint. So that means that if something takes 200 milliseconds, if I can make the server do something for 500 milliseconds, it means that I'm either going to make the server work really hard, or maybe that service, or maybe that database. I've seen cases where I make one request to her, she basically acts like an explosion, where she's going to make 25 internal requests. One of them is to you, where you get 3 megabytes from the database, and then it comes to you, and then you process, it goes to him, sorry, to her, then she gives me back. Guess what? I hit you 10 times, you just generated 50 megabytes. I hit you 1,000 times, you just generated 5 gigabytes of data internally, right? And then what's really cool sometimes is you scale really well, right? So you have a nice pipe, you have a nice queue. Guess what? I overload her, she puts that to you, everybody now goes into a little queue. By the time you're able to respond, all the browsers are gone. Meanwhile, you keep the valid users now servicing you because they keep putting on your pipe. And he's struggling, but you're okay because you have a nice little queue that you don't particularly care, right? But this is interesting, right? Especially in the microservice world, you have these cases where if you don't understand what happens with your microservices, you lose control, right, of what's going on. Now, the reason I created the O2 platform, by the way, now some of the models I'm going to do is I go to platform in Node and in JavaScript, is my big frustration 5-7 years ago is I could do this, but I couldn't describe it. I couldn't talk the talk of the developers. So what I've done, and I believe I evolved, is now the way I do this is I write tests, right? So the way this works is basically I've now write tests that look like this. So what I'm doing here is so now I'm able to write, I created DSL, a domain-specific language, which basically this is using CoffeeScript, because I really like CoffeeScript. I think it makes JavaScript a bit more sane, right? Especially coming from Java and .NET. So basically you have classes and all that jazz. So I created a little nice DSL where I can just go, this guy, give me the search, and that's going to hit down with the name, right? And also for the data, I'm going to get the duration, and then just the data nicely parsed. So I can now go, and I can be scientific about this. I can say if I do an empty search, I get 0 results with that amount of time. If I say search for that guy, I'm going to get 1 result. If I search for Doug, I'm going to get 31. If I search for Doug, %25, %25 is the percentage sign, which basically means I'm hitting a wildcard, right? So I just confirmed that I can do wildcard searches. I hit 48, then I hit DO, I get 736, then I get 5,000, and if I search just for the wildcard, again, I get 5,000. Now, there's already a quality problem here. There's no way the server should be sending more than 50 results back. There's no user going to read it. You're just polluting the whole thing. Right? So it's a quality thing. The problem with this is and Node is beautiful for this, right? If you guys want to do performance tests, all you have to do is create a UI thing and then do something like this where you call basically whatever you need to call. And sometimes this is go there, log in, do this, do that, and then you just do a nice little async, right? And to be honest, this is almost ridiculous because I only have to send 3 requests. Usually you have to send like 5,000 or 20,000 requests. But even though, right, if I hit a service with 10,000 requests, which is nothing, right? If you have any help decent server, that doesn't feel like a lot, right? Will the server collapse, right? And we know this is ridiculous easy, right? This will actually send 10,000 parallel requests, right? And again, if you want to be more funky, you can always create a nice little script to fire up a whole bunch of VM on Azure and on AWS, right? Or you can write a little nice, if you want, what's it called, cross-site scripting exploit that will be delivered by all the browsers. So again, very hard to detect. Now, so let's see this in action, right? So basically, what happened here is, and you guys can try this if you want. If you guys want to open up this website on one of your browsers, right? manifest.allyourphones.craftmachine.org. What will happen is I'm going to refresh it. You can see it comes reasonably quickly, right? Pending that's coming from my phone, but okay. Now what I'm going to do is I'm just going to run that test. Not that one. I'm going to run this test here. So this is going to send the 3 requests. There you go, 1, 2, 3, and the website's down, right? And this is going to be one of those, like, you know, I can tell exactly when you're going to come back, which is when my tests return, that website is going to return, right? So there you go, 3 requests, then it'll serve the whole website. Doesn't take a lot, just find the subspot, find the web service that is really expensive, hit it, and then you see the whole thing run into a halt. Right? So again, it's a quality problem, right? The first one comes down, right? There's going to be the second, and the third, and then that guy's going to come back to life, right? So, so this is the kind of test you guys need to do. So this is what I would put. These kind of tests are in my security pile. Okay, usually you don't need to deny of service the whole thing. You can see, oh, actually timed out, but there you go. Eventually return. If I send 10 requests here, that website will be down for quite a bit longer, right?
Maybe you have blocked you.
No, they haven't. Because I just did it from here, right? You have to remember blocking IPs is really hard, right? Because actually what are they blocking? Are they blocking Skype's whole IT? Are they blocking, you know, actually I'm coming from the O2 network, right? So if they block my IP, they're going to block every single O2 user. Because I don't have to have an external IP address, right? So just another one, since some of you guys might not have seen beef, right? So I've also introduced this here, right? Actually, I need to, and actually usually, so I forgot to bring, but I don't know if you guys have heard about this, the Wi-Fi Pineapple, right? Basically, and I was supposed to provide this, sorry about that, right? And I had this last time. This is basically things you can buy. They don't cost a lot, and they basically these nice little hacking Wi-Fi toolkits. Right? And basically these are designed to take over Wi-Fi networks, to pretend to be Wi-Fi networks, to force you to connect Wi-Fi networks, crack into the Wi-Fi network, right? Basically the Linux, right? It's like Raspberry Pi, it's just nicely condensed with some nice big antennas, so I can be next door, break into this Wi-Fi thing here, right? And they also have these like little kits here where, and what's sometimes scary is that you try to buy this thing, and a lot of times it's actually out of stock. Right? So, you know,
it took me 3 weeks to get mine. It took me 3 weeks.
Exactly, right? So the other one I have, which is really cool, is this one here, right? And so I got, yeah, the sold out stuff are really scary when they have that, right? And so I got this little toolkit here. Where is it? Where?
Go back. It was on the previous page.
It was on the previous page where I was here.
You mean the full toolkit? They're always sold out of it.
Yeah,
they're sold out of it all the time.
So this is pretty cool. So I got one of these, right? So this toolkit here, what it is you have a whole bunch of stuff. So there's a smaller version of the Wi-Fi Pineapple. Again, that's that with a little antenna there, battery. This guy's a key sniffer. That dude is pretty cool. That's a little USB stick, which is basically, it's called the rubber ducky. What that does is you put that little USB stick and it becomes like a keyboard. So it pretends to be a keyboard and a mouse. So guess what? You guys can do stuff on your keyboard and your mouse. Now you can program the whole thing. It basically has Arduino and you just pre-program the stuff. Again, if your security model is based on the fact that every developer that you have is authentic, every user you have is good, every app that you freaking get from Maven or an NPM or NuGet has no malware on it, every Chrome extension that you guys install on your box, because every software, all of those guys are benign, then you're going to really struggle. And all the code that you wrote to secure, you're really screwed, right? Basically, you depend on the fact not being attacked. For me, the best security model is where you depend on the attacker not making a mistake. That's the name of the game. The name of the game is to create systems that, in a way, sometimes being easy to hack is not a problem, right? As long as you're paying attention, as long as you control, as long as it's you playing the game, not the attacker. Of course, there was a great talk by the guy from the NSA, I don't know if you heard. There was the head of the NSA telling people how they hack them, right? It's pretty cool. So this is how we hack you. And basically what he said is, if you don't understand your network, right, you can't protect the network. That's that simple. So he looked at you and says, he has guys, I don't know what company you work for, but if you work for this company, he has guys that their job is to understand your network better than you, sorry. That's their job. That's what the attackers will do, right? And I have a couple of better examples for that. So when you have this, you can be in the middle. So what can you do when you're in the middle? So let me show you. You can do stuff like this, right? So I'm now simulating what will happen if you were browsing the website, right, with being Proxy in the middle. So I actually wrote this open source project, Proxy, which you guys can get from GitHub, which allows you to programmatically do man in the middle. So this does a couple of things. The first one, it takes away the S, so it does like the SSL strip, if you guys know. But programmatically, you know this one line of code, right? Replace HTTP with HTTPS. Sorry, HTTPS with HTTP. It also allows you to put payloads like this. So of course, the joke here is the security ID has not been launched, but I can change the homepage of the BBC, right? The other thing that you can do is you can see, if you go to main BBC, now you'll be, oops, it helps if the proxy is connected, right? Just a second. And here we are. Where's my terminal? Okay. And and basically here's my proxy, right? So what happens, what's interesting about this is, normally now is when you would go to SSL, but the point is if your website does HTTP to HTTPS, you might as well not do SSL, right? It's basically security theater. If you don't do 100% SSL, it's security theater. I would actually open a ticket in on your bug system saying our security for SSL depends on the fact that the attacker that we're trying to prevent is not there. Because if you're trying to prevent man in the middle, and when the attacker is in the middle, he can compromise you, then it's not really good protection, right? It's almost like it only works when the attacker is not there. So it's much better to be explicit. So here again, you hit this page, and not to credit to BBC, they're going for SSL. But you need consistency, you need focus, right? It's actually very important. And it's not just flicking SSL everywhere. You need to do HSDS, which is the header. You need to register with Google. You need to make sure your cookies are all marked as secure. There's a whole bunch of stuff. You need to make sure that you don't support old ciphers and all that kind of jazz, right? But a really cool demo, and this is great for developers, right? Is, and for managers, actually this works even better for managers, right? What you want to do when you get one of these things is you basically are going to put, what's it called? You're going to put Beef in there, right? So this is basically Beef. So Beef is a browser exploitation framework, right? So this guy should connect if Beef is on, hopefully. Let me just see if my demo's, yeah, that should be there. Right, so there you go. So, and then very quickly, and just for some of you guys haven't seen Beef, you can create something like this, right? I can put Flippy over there, right? Which is always good, right? I can ask the user to log in and give me his password, right? Which is, should be something like this. Actually, it might not be this guy. Well, okay, so the demo, okay, this one might, okay, there you go, right? You can ask the user to enter his password on Facebook, which is always nice. Remember, this is the BBC website, attacking the user, right? I can ask for the user to download some stuff. Let's say put something on Firefox, right? So there you go. So there's a nice little thing over there, right? I can ask the user where he is, so I can figure out exactly where he is, so I can do geolocation, and I basically eventually I get this thing. And if you show, and of course, if your website already asks for this, then that'll be transparent. And this guy should now give me the result. And here we go, right? And now basically this should be where we are, right? So again, this is the same thing you get with cross-site scripting, right? This is where we are, right? Yeah, just about, isn't it? There you go. So this is what it means. When you have man in the middle or cross-site scripting, it means this. It means the attacker can control. The attacker can sell access to your users on something like this. Right? Again, this is very crude. The attackers do this way, way better. Right? So again, just a nice little demo to give. And again, this is great for developers and managers, right? Because they really kind of freak out. And the other thing about this is I'm actually using ngrok, and ngrok is a great redirection service. So if you think about it, when I hit this page is hitting ngrok, which is a redirect that's hitting my laptop, who's hitting my VM, who's hitting my Docker, who's hitting my Apache. Right? This is why, if this was in China or in another country, there's no way they could track it to me, right? That's why when they catch the guys, they're always kids, because it's all the freaking kids who do this stuff from their home bedroom, right? And then get caught. So, all right, let's go back to the presentation. Right, so here's an interesting question for you guys, like how secure is your code? Right? But in fact, if anything, it's interesting, how insecure is your application? Right? How many risks and vulnerabilities? And the way I look at it is, if you don't know of 20 to 30 risks of your application now, means you don't know about them. These days, when I look at what's interesting, when I look at a graph of the risks that exist in an application, I'm worried about the applications that I don't know anything about. Right? That's the ones I'm worried about. So basically, the thing about this is, you have to make sure that it's your boss who gets fired, not you. Right? And his boss, and he should make sure that his boss gets fired. And this should be all the way to the CTO, to the board level. What I found, what's really interesting is 3 years ago, when you would get to the board or below, there'll be a buffer. They'll go, yeah, we'll care about it, right? Where what you have now is the other way around. What you have now is you have the board saying, hey man, what's going on with security? And when they get these really fluffy answers, they start to get worried, right? Because they know what that means. I remember this company where I read the annual report and it says, you guys know more and worry more about a freaking dam that is 5 kilometers away from headquarters that might explode. You have all full-blown contingency plans for all of that, and you don't know what's happening with your applications. Right? So, there's a bit of asymmetry here, right? So today you'll find that the board level and the guys below, they care about application security. Well, a lot of times they don't have these good solutions, right? Which is kind of where we still are. Now, this is the workflow that, in a way, I'm very synchronized with what Sheriff is doing. It's very similar. One of the things I tend to do a bit more is I actually call this a risk. I have on a separate JIRA project, I actually have this flow where once we identify the problem, I very quickly force, and basically the flow is the developers need to actually, and the business, not developers, the business owners, they need to define, are we going to fix it, or are we going to risk accept? And then there's a nice little button here, which is accept risk. And I guarantee you, that little button will do more for your application security than anything else. Because it's that little button that makes those business owners basically responsible. And they know it. And they totally know that you are gaming the system. So the way I look at it is like, I'm basically thinking, I'm now hacking